So there, we are now recording. This is the second lecture in week number 13, and that means that this is lecture number 26, unless we missed one or two for a test or something. I don't even remember. Who cares? It's just the next one. I'm going to start sharing my screen. So here we have more on correlation and regression. Now, do we remember this chapter? Okay, let's recap what we've done so far. We have done correlation, which connects two quantitative variables, and we had a chapter on that. And then we talked about regression, which is finding the best fit line. We certainly had a chapter on that. And then we started this new chapter, which is kind of giving us a rationale for the understanding of why R is positive when we have a graph that goes up left to right, and why R is negative when we have a graph that goes down left to right. And we talked about that. If you look at the formula for R, we see that we have lots of positive values in the top right and lots of positive values in the bottom left. And therefore, a graph that looks like this, we would expect to have lots of positive values occur in the sum that defines R, which is currently on the page. And if a graph has a negative correlation, it would have exactly the opposite effect. We would have the expectation that we have lots of numbers down here in the bottom right and lots of numbers up here in the top left. And therefore, if we have a graph that looks like this, we'd have a lot of negative contributions to R. Does that make sense? This is what we did last time. Hopefully you've had an opportunity to think about that and to go over it and to look at it.
That makes more sense now than it did last time.
Is it because it's had time to settle, or because you spent time studying over the last 2 days to try to understand what I was talking about?
I think because of both things.
Okay, well, that just stresses the idea that when you first learn something, when someone's explaining something for the first time, quite often what happens is it goes into short-term memory. You're not really understanding because you don't really have a basis to understand. You're learning something new, and it's all new concepts, and you're trying to figure out what I'm talking about or what your teacher's talking about, and you don't have time really to digest it because the teacher's moving on to the next thing. And then what happens is you think about it for a little while, and you come to some realizations. You recognize certain features, and you get better, and you learn more, and that's just the learning process. So that certainly makes sense. So we did a lot of that stuff. And then we did R squared. We talked about the R squared value and what it represents physically in terms of, can someone remind me what R squared represents physically? Anyone remind me? We spent time on that. We spent a bit of time on that. What does R squared physically represent? Because R has no physical representation, but R squared does. So what was R squared? Who can remind me, please? So Lair, is that your hand up? I can't tell. Okay, so Lair, go ahead. What does R squared represent?
Wasn't it basically saying like the value, whatever R squared is the percent for the variability that is directly related to X or something?
Yes, that's very, very good, right? I don't know. We'll have a quiz. I don't know. I don't want to have a quiz. I have to grade a quiz. I don't think you should have a quiz until I grade your test. That should not be fair on you guys, right?
Yay.
Oh, that's fair. Why would you have a quiz before I can even get your test back? Yeah, so no quiz yet. But yeah, so R squared. So we know that the Y values are not going to be all the same. The Y values are not all the same. We have points here and here and here and here. You got points all over the place, right? They got all different Y values, correct? So because they have all different Y values, then what you expect to occur as, well, you have different Y values, right? They're all over the place. The question is, why do they have different Y values, right? Why, in the example that we did, which was this grade example, why are the grades not all the same, right? And the first obvious answer is the grades are not all the same for the simple reason that the absences are not all the same, right? That's the whole point, right? That the absences dictates the grades. And if you change the number of absences, you change the grade. It seems very reasonable. But then you look a little closely and you realize that, wait a second, if you look at the very first one there, these guys right here, we see that they actually have the same number of absences, yet even so they have different grades. So the question you ask yourself then is, wait a second. You say, how is it that if we have this formula which connects absences to grades, we see that the same number of absences actually gives a different number of grades? And the answer to that is that, well, obviously absences alone was not enough. Absences might have been one reason why the grades are different, but there are other reasons why the grades are different. What are some of the other reasons why the grades are different? We talked about a few of them last time. My other class came up with a few other ones. So what are some reasons why the grades might be different?
Differences in IQ.
Differences of IQ. Some people are just smarter than others, so maybe they don't have to come to classes often. Myself, I would skip classes a lot because I study on my own. We don't know how much time people are spending studying on their own, right? How much sleep they had, what they ate for breakfast. I mean, there's plenty of reasons why their grades are going to be different. So the Y values vary. There's two reasons why. One is obviously absences, and one is everything else. So what the R squared value measures is how much of the reason why the Y values are different comes from the absences versus the everything else. The more that it comes from the absences, the better our model. The stronger it is, the higher the correlation. Okay, the worse the strength, the more it's from everything else. Okay, and we actually did a little math with that. We went through this. We computed the TSS, the total sum of squares, and the SSR, the sum of the squared residuals, and we calculated their ratio, which was the percent that comes from the everything else. We did that, and we saw that 1 minus that gave us the R squared value. So we have this connection between them. That's all we did last time. And we got all the way. Did we do this? I think we started this, correct? We started this. And actually we got to here. I believe we did more than this, correct?
We got to page 13 and that was it.
Got to page 13. Okay, so let's start here. A formula for the regression line. Okay, so where are we going to go for a formula for the regression line? We are not deriving this formula. Okay, this formula they're just straight up giving us, and we're just going to straight up use it. Y hat, which is the predicted value of y for a given x, is equal to y bar, which is the average y value, plus r. What is r equal to?
Can you sorry, can you repeat all this? I was trying to write.
I'm just reading what's on the page right now. I'm not doing anything different. What does the page say? Y hat, which is the predicted y value.
That's what I'm talking about. Like what you're
what everything is. So yeah. Y hat is the predicted y value. Okay. Y bar is the average y value. The average y value came from what?
Adding up all the y's and dividing by the number of y's.
Yes, but I'm saying I don't mean the formula for it. I mean, where did it come from?
We had that chart on page 7.
Yeah. I'm sorry, I meant R. I was a little confused with myself. Y bar is the average y value, right? You add all the y's and you divide by how many there are. R is the correlation. We had a formula for the correlation. What if I don't want to use that formula? What if I just don't want to use that formula? How do I find R if I don't want to use that formula?
So get in a calculator?
That's one way. And that's a perfectly valid way, by the way. I'm not saying it's bad, especially in a class where you just don't want to really do it, right? But there's actually another way of doing R besides that.
Mm,
Do you square it? Oh,
Um,
nope.
Is it this big formula right here? On the, like page 3.
well, that's the first way. The first way is by using the formula. The second way is by using a calculator. And the third way is actually kind of tricky. You kind of work backwards. It's by doing this. This little table here, which gives you the TSS and the SSR. Then you can calculate SSR divided by TSS. And then 1 minus that is R squared. And then you take the square root of R squared, you get R.
right.
So it's like a roundabout way of getting there. But I think it's easier than the other formula, but that's just my opinion. So we have the formula for the regression line. Okay, so then we have S sub y over S sub x. What is S sub y over S sub x?
Standard deviation of y over standard deviation of x.
Standard deviation of y over standard deviation of x. And then you have times x minus x bar. X is what? And x bar is what? Well, x bar, yeah, go ahead.
It's one data value, the x of that data point, and then minus the mean for the x's.
So which data point you're going to use?
Any.
So you're going to get a different answer than someone else if they use a different data point. Is that what we're suggesting?
Is that what you're suggesting?
Is that what you're suggesting? So the answer is, remember, y equals mx plus b has the letter y and the letter x there. That x represents any data points that you can possibly come up with, not a specific one, but any of them. Just like when you have y equals mx plus b, x is anything here and y is then anything here.
Mhm.
Well, that x, you don't fill in with anything. That x is literally the letter x. Literally the letter x. So you calculate x bar, you calculate y bar, you calculate sy, you calculate sx, you calculate r, but the letter y hats and or the symbol y hats and the letter x remain in your answer. Let's do this example here. We have a scatter plot that shows the scores of a group of students on 2 tests. I would like us to come up with the best fit line. Y hats equals. What's the first thing we write?
The mean of test 2, because that's the y value.
Good, which is what?
70.5?
70.5. They gave us that.
Figure out R,
Plus R they gave me.
which is where?
And then
Oh,
you
0.75.
yeah, plus 0.75.
Yeah, but we're going to combine all that into a single number. So I'm waiting till we have it.
Oh, so it's
25.
0.75 times
18 point,
Now S sub
or
Y.
19.5.
S sub
19.5
Y
over.
over what?
over 18.1.
Over 18.1. What do we get? I have what my calculator gives me. What do we have in your calculator?
Can we write out the whole equation first?
Well, oh, you just want to write everything down.
Yeah.
Yes.
Okay, so 0.75 times S sub Y, which is how much?
19.5.
19.5 over
18.1.
S sub X, which is 18.1 times
Times,
X.
oh yeah, x is,
parentheses
yeah, x minus 73.6.
X minus X bar, which is 73.6. Does that make sense?
Professor,
Yeah,
where did the 0.75 come from?
that's the R.
Oh yes, my bad.
All right, here's the letter R. They tell me what R is, right? That's the letter R. Correct?
So does X bar mean the mean of X?
Yeah, that's exactly what it means, which they told me. X is test 1, so that's 73.6.
Okay.
All right. Make sense? And then, of course, you can combine it together. So we get equals to 70.5. What do those three numbers give you when you do the math?
I got 18.477,
For these three?
right? No,
No, that doesn't make
just
sense.
kidding.
That's a good joke.
This is kind of a basic question. Would you divide first, then multiply by 0.75?
Personally, I would multiply and then divide, but you can divide and then multiply. Either way gets you the right answer, as long as the right things are on top and the right things are on bottom.
Is it
Okay.
0.81?
Yeah, approximately 0.81. That's what I get.
Oh, I think I added instead. Oops.
Oh my God. So that is the equation of the best fit line. Does that make sense?
Yeah, hang on a second. I'm trying to calculate it myself.
No problem.
Yeah, that's all though. Only one of them. I don't know. And no, she
So is y hat, do we solve it? So is y hat 130.12?
No, how can you do that? What happened to the X?
Oh, just kidding.
You don't, X is an unknown. There's no solving. This is the answer. This whole equation is your answer.
Yeah, just kidding. Sorry.
Oh,
I didn't bring the X over, so I just did like 0.81.
I got,
OMG.
if we're gonna write it kind of like y equals ms plus b, I got y equals 0.81x plus 11.03.
Oh, you mean you multiplied it?
Yeah.
Hold on.
Do we have to multiply or can we leave it like this?
Yeah, either way is fine. So what do you get to there?
I got y hat equals 0.81x plus 11.03.
That's right. Which means the y-intercept is about 11.03, which goes about there. Right, so we have some line that looks kind of like a.
Professor, do you mind moving your screen up just a little bit?
My what's over?
Your screen, or your whatever you're sharing, can you scoot it up a little bit? Oh,
Can you not see the bottom?
maybe it's just my screen. I don't know.
I mean, what's the last thing you
I can't
see?
see what you wrote on the right, like at the bottom.
0.81x plus 11.03.
Okay. Thank you.
Professor, that answer, the 0.81 plus
What was that? What's your question?
what you just got right now, the 0.81x plus 11.03.
Yeah.
What did you do with the 70.5? Did you add it to the 0.81?
No. I distributed 0.81 times x, and then 0.81 times negative 73.6. And then I can't do anything with 0.81x because it's not like terms with the others, but these I added together. 70.5 plus 0.81 times negative 73.6. Those I added together. And that gave me 11.03.
What was it? Say that one more time, sorry.
I distributed.
Uh-huh.
Solaire's writing it out. I'm going to spotlight her.
So, sorry, this is a stupid question, but how did you place the line then? I mean, how did you get your other point? How would you get your other point? You need two.
What other point? I don't even have 1 point.
Well, I see you have 11.03 as your y-intercept, right?
That's right. Yeah. Oh, how did I make the line?
Yeah.
Oh, I just approximated.
Oh, okay.
I just said, okay, here's my y-intercept, and this line seemed to work, so I just made a line.
Well, so if you didn't want to just wing it, how would you
Then-
make a,
Then I would plug in some X value,
okay,
calculate its Y value, plot that point, and then draw the line that
Okay.
connects.
okay, that's what, okay, thank you.
You're welcome. So
Hello, we can, thank you.
Larry's awesome. I won't thank her for doing my job for me. Okay, so
You know, it would be really cool if it was like that, what is it? Not Wheel of Fortune, but when you touch the tile and it appears.
That is Wheel of
Wheel of
Fortune.
Fortune.
Oh, there you go.
Solar White.
You're Vanna White. That makes you Pat Sajak.
Yeah, Professor.
Come on down. What?
Professor,
Yeah.
I kind of still don't understand what you do with the 70.5.
With the what? I'm
Oh.
sorry.
So 70.5 we combined with negative 59.4. You did 70, you combined these two.
Oh, so you
Do
add those.
70 minus 59.4 and you end up with 11.03.
Oh, okay, I see now. All right, cool. Thank you.
All right. Okay. So
Can I not be spotlighted anymore?
am I not sharing? You don't see my screen?
Oh, you're sharing, you're good, you're good.
Okay. All right.
Does Solaire get extra credit for this? Because I'm about to call whiteboard too.
Yes, so Larry gets extra credit.
Yay!
I don't think she'll need it, but she gets it. All right. So it said find the equation of the least squares line. We just did that. Graph the line above. We just did that. Now, better question. What does the regression line predict that a student who gets a 40 on the first test should score on the second test? How would I figure out that one? Unfortunately, Solaire just erased her equation, which we can use for this.
Oh, I can
But
write it again.
it's okay. It's okay. So what does the line predict?
So would we put 40 where the X is, or?
That's exactly 40. X is the first test, right? Right. So if
What's 0.4 times 81? 0.81. Sorry.
0.4 times 81,
Sorry, 40 times
it's
0.81.
about 32, give or take. So plus the 11 point whatever.
43.43.
43.43. So we expect the line predicts that a student who gets a 40 on the first test should score that in the second test. Now, one student was sick for the second test. It's too late to give her a makeup. Rather than penalize her with a 0, you can impute a score for her for test 2 using the regression line. What would that score be? In other words, if she follows the pattern like the rest of the class does, then you should give her a 43.43 because that is the predicted score that she would have gotten. Does that make sense? In other words, you're basically saying the class trend is that people with scores on 40 on the first test would have gotten a 43 on the second test. So rather than giving you a 0, I'm going to give you what I think you would have gotten had you actually taken the test. I know teachers who actually do this, by the way. Right? If you have a legitimate excuse for missing a test, they will give you what the class as a whole trends toward on the second test.
What is that like the class average or is that?
No, not the class average. You take all the grades for the class and you compute this line. And this line is the predictive line for how people are going to do in the Y values versus the X values. In other words, their first grade is here. The line predicts that their second grade is here. If I don't have an actual second grade for you, then I'll just use the line to predict what you would have gotten. Because that's what the line does. Especially if it's a high correlation, that's exactly what the line does. The line predicts Y values. Okay, so that's the purpose of the line. Now, the regression effect.
Wait, Professor, so
Yeah.
what would it be? It would be 43.43?
43.43. That's the law. That's the grade that you think she would have gotten had she actually taken it.
Okay, thank
So
you.
let's give her a 43.43. So the regression effect. Most people would expect that a man's sons would grow up to be about as tall as he is on average, and that a woman's daughters would grow up to be about as tall as she is, again, on average. What is the reality? So we have the regression equation that y hat equals 0.5x plus 34.7 to predict the height of the son of a man who is 6 inches taller than average. To predict the height of the son of a man who is 6 inches taller than average. How does the son's predicted height compare to the father's height? I think what we have to do for this one is go all the way back to here. The average father's height is 69.4 inches, correct? So let's write all this information down. Let's use this information to see if the best fit line that they gave us is actually accurate or not. So copy this information down because we're going to scroll down to another page. Okay. So let's go ahead and check whether or not their equation that they're just giving us is correct. What is the equation? Y hat equals, what should it be? Y hat equals
0.5x.
No, that's what they're giving us. We're going to derive it. Let's go back to the formula for the best fit line. Y hat equals Y bar plus the whole thing that we just did.
Oh,
What's Y bar?
y bar is,
That be 69.4?
yeah.
Well, yeah. So the average Y value, which is the son's height, because fathers are predicting sons. So father is the X, sons are the Y. Y bar is 69.4 plus, what's the R value?
R was 0.5
0.5
times
SY.
3/3.
SY is 3, SX is 3, parentheses, X minus, and what was X bar?
69.4.
69.4. So the 3's cancel. 3/3 is 1. I get 69.4 plus 0.5x when I distribute, minus 0.5 times 69.4, which is 34.7. So I get equals 0.5x plus 69.4 minus 34.7, which is 34.7, which means their line that they gave us is accurate based upon the data. Now, if a father is 6 inches taller than average, what does that make his X value?
6 plus the mean?
Well, that's the average, right? Right? If the average is 69.4 and he's 6 inches taller than average, then what does that make his X value?
Plus
Huh?
75.4.
So let's plug in 75.4. What do we get?
Times 95.4. 37.7 plus 34.7. 72.4.
72.4, which means if the father is 6 inches taller than the average, the expected value for the son is actually 3 inches taller than average. And what if,
Sorry.
it's okay.
Are they always going to give us that information that we just saw in one of those slides?
I
Because
can't comment on what they're always going to do.
okay, because I didn't even know we had that information.
Can
So
you
what?
spotlight
let's
Torlair,
take-
please?
Spotlight Solaire. You didn't like what I was doing? You like what she's doing? Solaire, take my money, take my job. I'm taking a break.
Please. I
Wait.
need the
Hilaire, so how did you get the 37.7 and the 34.7? Yeah, you got it from there, but then
right here.
no, at the bottom.
Okay, so we put this x into our x in the equation
Okay. Okay.
and
Thank
we
you.
multiply.
Got it. Thank you. Sorry.
It's okay. Solaire's wonderful. Right? Everyone?
That is correct.
No one's,
Professor.
I'm really visual, so this helps me. That's why I write it on the board.
that's
And
great.
That
That's
helps
great.
us too, Solaire.
Well, but that's what I was writing. I thought I was writing that.
Solaire's better. Sorry.
Wow.
Oh,
Wow. Okay, so remove,
Professor?
how do I remove spotlights? Oh, here, remove spotlight. Okay.
Professor,
So,
finish what I was asking.
huh?
Can I finish what I was asking?
Sure.
Okay. So what I'm asking is, in the future, because the way I did that was I didn't know we had that information above, or I didn't remember. So I just took the 34.7 and divided by the 0.5, and that gave me 69.4. Would
Yeah.
that work? Like in the future?
If what?
Would that work like in the future for anything?
I don't know. I can't say.
So that
Ask
would be
Solaire.
Huh?
Ask Solaire.
what was your question?
No,
I
Tomas,
took
Tomas,
34
every problem is different. I can't say what's going to happen every time. I don't have an
No,
answer.
I understand that. What I'm just trying to ask, is that a correct way of doing it?
Huh?
Never mind.
No, Tomas, I don't understand. A correct way of doing what? I don't understand your question. I'm sorry.
So I took 34.7 and I divided that by 0.5, which gave me 69.4. So in a case where we had a problem like this, if we didn't have that information, would that be a correct way of getting that information?
Why'd you divide?
I don't understand what you did.
You divided?
Okay, you know how we got 69.4 as a height? So I was trying to find the average height.
Oh, that was already given.
No, I understand that, but that's what I'm asking. If it wasn't given, would that be a correct way of trying to find it? Because you
No.
say you don't know if it's always going to be given or not.
No, that doesn't. No, I mean, every problem is different. You have to be given enough information to solve it. But I mean, what I'm saying is,
Oh, did you just take the regression equation and solve it for x or something?
Yeah, so I didn't even go through I didn't go like where you guys started from. I started from just what we have, and I found the average because I was starting it right before you even did it. So I didn't go back and find that information in the slides. So I just took 34.7 and divided that by 0.5, which gave me the average of 69.4. And that's how I did the problem.
that I think is a coincidence.
Okay, that's what I was just asking.
I don't see that working every time.
Okay.
I don't see that. No, I think that was a coincidence. I
I actually understand what he's trying to say. Like,
Yeah, I know what he's trying to say. I think it was a coincidence is what I'm saying. I think because of the 0.5, it happened to work out that way.
oh, okay, but it would typically wouldn't work out the way that we could just plug it in.
No, it would not.
Okay.
It would not. So, yeah. So, I mean, that's. Yeah, I don't think it would. I think it's a coincidence. I would recommend Tomas. Yeah. So I hear what you're saying. Like, you had to go back a number of slides to get the equation. How did you know to do that, right? So any test question that they give you is going to have to give you enough information to solve it without you having to realize that you have to go to a different slide.
Okay.
Okay. But in this case, I'm here to explain how it's connected. Okay. So So yeah, and so now, so Solera, when I close it down, I lost it. So what was it? It was y hat. Oh, never mind. They gave it to me. Okay. So what was the average again? What was the y average? 59.4, correct?
Yeah.
Okay. So we know that the y average was 69.4. So now what we saw, let's go back to our results. When x was 75.4, what was the predicted value? 72.4.
Yeah.
Okay, y hat was 72.4. Okay. And here, if x is equal to 6 inches shorter than average, what's 6 inches shorter than average?
69.4 minus 6,
Which is
63.4.
63.4. If you plug that in, what do you get for y hat?
Hold on.
No problem.
I got 66.1.
60, okay, let's assume that's correct, 66.1. So what do you notice in both cases, and this is not x bar, it's just x. What do you notice in both cases about the predicted value compared to the x value?
Oh,
What do you notice in both cases about the predicted value and the x value?
I noticed something.
What do you notice? Which may or may not be what I'm looking for, but what do you notice?
So, technically, our line is 0.5x plus y, right? Plus the height. So the 0.5 means you're going up and across half. So if you're increasing or decreasing by 6, the result's going to be half of that, which is 3.
100%. There's no question about that, but that's not what I was talking about.
Oh.
What I was saying is you'll notice in both cases when the father is taller than average or shorter than average, the son is predicted to be closer to the average than he was. When the father was taller, the son is closer to the average. The son is shorter, but closer to the average. When the father was shorter, the son was taller and closer to the average. In both cases, the son's expected value, his predicted value, is actually closer to the average than the father was. Right? Let's look at a number line. Here's the average, 69.4. Where's the father? The father's here at 75.4. Where's the son?
6 inches taller.
No, the son was 72.4.
Oh, right.
The son is here, which is closer to the average. And in the other case, here's the average. And what we have here is the father was at 63.4. What was the son, according to your math?
66.
66.1, which is closer to the average. So this is what's called the regression effect. The regression effect is that statistical data tends to get closer to the average rather than further away from the average. Here's another example. Who here likes watching baseball? Nobody likes baseball? Damn, I had a great, okay, how about basketball? How about football? How about any sport?
I watch baseball.
Okay, baseball. How often does a rookie have an amazing season?
Not very often.
Not very often. Not very often. But when a rookie does have an amazing season, what usually happens the next season?
He doesn't have the same outcome.
I still got one more lesson.
What?
Okay. Hi.
I don't know if someone's talking to me or someone's talking to someone else. But back then, if a rookie has an amazing season, what usually happens the next season?
It's not as, I don't think it's the same.
It's not, usually they're not as good the second season.
Yeah.
It's called the sophomore jinx or something like that, or the sophomore curse or something. I don't know exactly what it is, but usually sophomores, the second season, it's not as good as the first one. And the reason is not that he's doing a lot worse the second time because, he's having a bad slump or something like that, but because statistically, when a person or something scores significantly better than average, what usually happens the next time? They get closer to the average. So when someone has a very good season, the next time they're probably not going to have as good of a season. Now, if they're just a superstar, then their very good season is their average, is their normal, right? And they just stay there. But quite often what happens is someone just happens to have a very good season. It's a statistical blip that you are better than you expect it to be. And then what happens? You regress towards the mean. You get closer to the average every iteration, every step down the line. This is called the regression effect. Does that make sense? So there, question?
So if I were to put this in like a definition, could we say as the values of X increase or decrease, the expected Y value is closer to the average?
Yes. Well, say that again.
As
The
X,
values of X increase or decrease?
the resulting Y, the expected value will be closer to the average.
No, I'll say it a little differently.
Okay.
If an X is above average, the corresponding Y will be, okay, let me try that again. Hold on.
For any X value, the resulting expected Y value tends to be closer to the average.
Yeah, that's the regression effect. But I want to say it in terms of as the X value changes, which was your terminology. So I'm trying to come up with a way of saying that would fit what you were trying to represent.
Any change in X would result in a Y that is closer to the regression line.
No, that's not accurate.
Okay.
If you have an X value, which is above average, and you look at the corresponding Y value on the line, no, that won't work either. I'm sorry. I'm sorry. I'm trying to come up with a way of saying it that would really, I'm trying to come up with a way of saying it that would really make sense. I can't think of one. I mean, let's just read theirs. I can't come up with a way of doing it. So let's take a look at what theirs says, which is probably better written than anything that I can come up with.
Professor, can you go up? Sorry.
Up where?
Wait. Oh, right there. Okay, so you see how does the son's predicted height compare to the father's height? So,
yeah, it's closer to the average.
Oh, okay, that's all we had to say. Okay.
Well, we did the math.
Yeah.
We did the math, right? Okay. So since it's brought up, let's just read it. Let's see what they say. Suppose that you have two measurements for each individual. For example, the scores on a midterm test and a final exam. Convert each of the two tests of scores to z-scores. Then, as long as these scores reflect some element of chance, and they're not deterministic, the individuals who had the lowest z-scores in the midterm will tend to do better on the final exam, and the highest scores in the midterm will tend to do worse on the final exam. But even this is a definition which specifically applies to like midterms and finals. It's not a universal explanation. And that's why I'm really reluctant to, and it could just be that they don't even define it. It could be that they don't even define it. I mean,
I just Googled it and
Yeah.
there's not really a universal definition
yeah,
anywhere
it's
that I see.
yeah, which is, you can understand why I'm having a hard time verbalizing it, because if nobody else has come up with one,
There's one that Wikipedia has offered.
what do they say?
Regression towards the mean is the phenomenon that arises if a sample point of a random variable is extreme. A future point will be closer to the mean or average on further measurements.
Well, that's fair. But that doesn't really work with best fit lines and whatnot. That's more of a, well, I guess it does, but okay, so let's try this. Let me interpret what they just said. If you measure something and your measurement is above average, a future measurement will tend to be lower. Like, for example, your batting average. If your batting average is above average, the next year's batting average will tend to be lower. If you are taller than average, your son, the next generation, will tend to be shorter. So if a measurement is above average, a future measurements will tend to be lower. And if your value is below average, then a future measurement will tend to be higher. That could be the same, the same measurement, like batting average followed by another batting average. Or it could be something generational, like a son from the father. If you oh, she's writing it out. That's great. If you measure something and your measurement is above average, a future measurement will tend to be lower. If a measurement is below average, the future measurement will tend to be higher. But again, what is a future measurement? Is it the same thing that you're measuring, like batting average? Or is it something generational, like from a genetic standpoint, father to son? Both of them qualify for the regression effect.
How is the last part? If the measurement is below average, the future measurement will tend to be higher. How is that statistically right? Like if somebody's failing a class and not putting the work.
Nah, see, failing a class, that's the whole thing. Failing a class is not necessarily a random chance situation, right? If you're failing a class because you're not studying or you don't understand the material, you're not failing because of luck. You're failing because you did not put in the time that you needed to. Okay, the next test is not going to go closer to the average just because, oh, statistically it's going to go up. Okay, we're talking about a random chance situation. All right. Okay. When you're, when you're playing baseball, right? You ever play baseball? If you bat 280, then you hit, you get on base 28% of the time, right? You don't know on any given at bat what you're going to do because, the pitcher can throw randomly, you can swing differently, the players are going to be placed randomly, an error can happen. All these different things can occur that are random. Okay, so if it's a random chance situation, or even genetically, which is there's randomness in genetics, it goes closer to the mean. Not studying for a test and therefore not doing well, that's not random. That's just straight up, not doing well. You understand the difference?
Yeah.
Okay. So we don't need to worry about this. We don't need to worry about this. Now, I mean, I guess there is some randomness with exams because perhaps you'll get lucky and have questions that you know versus questions that you didn't know, right? You're taking a test, there's a bunch of questions. You ever take a test like that? You study and you realize, oh my God, I studied all the wrong things. They didn't ask me any of the things that I studied, right? So there is some luck involved in that, right? There's some luck. So when you have a situation like that, where you're studying and you understand some material but not others, there is luck involved. What are they going to ask me? Are they going to ask me the things that I know or the things that I don't know? So if you score below average on an exam and you believe that the reason is because they asked me the wrong questions, then there is chance involved. That is a random situation. And on the final, all things being equal, you still have studied the same amount, you understand basically the same amount and whatnot, then yes, you should tend to do better. But if it's not studying and therefore you're not studying anymore afterwards, then yeah, it's don't expect a big difference. Does that make sense? I feel like this explanation was not my greatest, and I apologize for that. It's hard. You can see even going online, it's tough to find a very good definition about it. We are going to skip this group activity completely because I don't want to do it. And that'll be it for chapter 17, which is the end of correlation and regression. Okay, so this chapter, I'll tell you what I'm going to ask on. I'm not going to ask on regression because I feel that my explanations were not the greatest. So I'm not going to ask you any questions on regression. What you do need to know are things about the best fit line and R, the correlation, and the SSR and the TSS. Because those are all things that we have formulas for. Those are all things that you can just plug and chug and calculate, plug into a calculator or do it by hand and get the answer. Okay. The regression stuff, don't worry about. I'm not going to ask on that. I felt I failed in a really getting it across well, other than conceptually, the idea that if it's a random chance, you can tend to go closer to the mean, but I don't feel that my explanation was the greatest. So don't worry about that on the test, which will be whenever it'll be. Okay. Is that fine? Is that a good compromise?
So
Yeah, thank you.
the regression part that you're saying is the whole like figuring out the average height of the dad and the son, like none of that stuff we don't have to worry about.
Well, yeah, I'm not going to ask anything on regression.
Okay.
Yeah, that stuff you don't need to worry about. But the other stuff in the chapter, which is the best fit line and the correlation, that stuff you definitely need to know.
How about just calculating the regression line?
Yeah, I mean that's plug and chug.
Okay.
That's a situation where you can just plug in SX, SY, R, X bar, Y bar. We did a few examples of that. People said, "Hey, how do you get this?" We took time. We went over it. So yeah, definitely that. Okay. We never actually calculated R from data, even though we had a formula for it. So I would not ask you to do that. A homework question might, but I will not ask you to do that. Okay, because we never actually went through that process in class. Okay, but once you have those values to find the best fit line, we did talk about that, and you can expect to be asked on that. Sound good? Questions? Thumbs up. So Larry, go ahead.
So just to plan ahead,
Yeah.
we're probably going to have another quiz, right?
We'll probably have another one. Yeah, let's say we'll have one more.
And then we're having like a final?
Then we have a final.
Okay.
Yeah, gotta have a final. Math department requires it, so we will have a final.
Mine will be the same way we've done the other tests, where
That I don't know. I have to talk to the math department about that.
I was gonna say, Professor.
Yeah.
On like my Canvas, I was looking at like my final schedule, or whatever, and ours is like scheduled for the 10th.
Yeah. So yeah, I have it on my phone somewhere. Yeah. Finals are different. Finals have scheduled times. Finals are not. I can't just
because that seems absurdly late.
If what? I'm sorry.
Is it gonna be from like 8 to 10 p.m. though? That just seems absurdly late.
I don't think
Yeah, it did say 8 to 10.
Is it?
It's 10. It's just an hour later from when we start class, so it's not too bad.
Yeah, but I'm a mom. Like,
I understand that, and it's not I don't make the schedules. If you feel that something is difficult, then that's something we can certainly take up with the math department and ask. But I can't.
Would there be a way to do like, since our normal time of class is 7, would you be able to make it at 7?
I don't know if I have that authority, so I have to find out. That's not something that I can just make. I can't just do that on my own. Because especially with the math department that I have, the guy in charge is very, very by the book.
Oh, that's
So,
nice.
So yeah, so I
Oh,
mean,
no.
I'm not saying he never makes allowances for things, but he happens to be a very by the book person.
Well,
Okay.
I mean, I guess maybe we
Yes,
could
one
make a
second.
suggestion.
Hold on. We do have class next Wednesday.
Okay.
Yes, question? I'm sorry, what was that?
I mean, if it's okay with everyone else, since we already have 7 p.m. dedicated to this class, if we could do it an hour earlier and then finish earlier, maybe.
Yeah, I'd be willing to do that because I don't really fancy staying anxious all day.
I would have to talk to them. I can't make that call on my own. That's
Okay.
something that I would have to address with the math department and he would tell me, but I can't. Even if everyone in the class said yes, I can't do that. So he can do that. He can say, well, if everyone agrees and you have it all in writing, and I mean, whatever rigmaroles, he'll say, but I can't make that call on my own. Okay, so as of now, it is, if it's 8 to 10, it's 8 to 10. Okay. Yes, no, maybe so.
And then does that mean we're on Zoom when we take it, or like? How does that work?
Well, the math department, I think the school does not require students to be on camera during classes, even though I know many of you are, like, Solaire has been very helpful by being in the class and a few others. But the school cannot, by law, require people to be on cameras. And therefore, because of that, you're not, even if it's on a Zoom test, in other words, you have to be logged on, you don't necessarily have to be on camera. Okay, but the format is unknown at this point. I do not know what the format is. So yes, go ahead, Tolaire.
I'm looking at the final schedule. It's saying math 211 is December 14
From what time to what time?
from 8 to 10.
From 8 to 10. December
14.
14th from 8 to 10. Not on a Monday. Okay. So that's what it is right now.
Okay.
Okay. Until further notice, that's what it is right now.
Sounds good.
Okay.
Can I ask a question? Like,
Sure.
this is my first year at CSUN, so like I don't really know. Like,
Welcome to CSUN.
okay, well, thank you. But like, for if we were actually in class,
Yeah.
sorry, would it be at like the same time our classes, or would it be like changed? Like,
No. You get a final schedule like on your season portal. If you go on, there'll be like the blue final schedule and
Yeah.
you just follow that. It would be like that. Like when you go to school, you'd go to class or sometimes a different location than your class to take the final at that time that it gives you.
Oh, interesting. Okay, thank you.
Yes. So, yeah, because the thing is that this is not the only Math 211 class. So the way the math classes work, especially with the other ones like Math 140 or the ones that have like 25, 30 sections. So they will have a common final that everyone in the class takes. And if everyone took it at their own class times, then questions and answers would get out, which is of course, not good. So they do everyone at the same exact time, no matter what time your class is. So there's a whole final schedule. It is cumulative. The final is cumulative. So it'll be on everything that we've learned, but still open notes, open books like the other ones have been, even if it is live as opposed to, hey, take the whole weekend to do it, which I don't think you'll find many teachers who would be willing to do that. So it's possible that allowing that gave you kind of a little disservice because it doesn't really prepare you as well for the final, which I don't think will be like that. Say again, what?
Could you ask
Can I ask what?
if it could be for like?
No. They tell me. I don't ask. They tell me.
Okay.
The math department decides. They don't say, oh yeah, do this. You can do whatever you want. You can do whatever you want. No, the math department says, this is the format, follow this to the letter or don't teach here again. Okay, that's the math department. That's this guy. So, whatever they tell me, that's what it's going to be. Okay. How I run my class otherwise, I do have a little leeway. How many quizzes, how many tests, when the quizzes and tests are, how I grade, etc. But the final is very, very, very department specific because they want to look at data and they want to compare different classes and how different teachers performed and how different students performed and where people were weak and where people were strong and where they can get better and whether this class was good and all these different things. And they use the final data for that. So the finals are very, very in line with each other. And will we get a study guide? The study guide is everything we've done. That's your study guide. I don't know what other study guide to make other than going down and making, know this, know this, know this, know that. Other than regression, which is the only thing that I specifically said, don't worry about. You got to know everything. Yes, still there?
Can I just confirm that I heard you say we could use our notes?
As far as I know, it's an open book, open note test.
As
Okay.
far as you know.
As far as I know, the thing is that my other classes are open book, open notes, which is why I am believing that this class will be open book, open notes. If next time I come back and say, yeah, I spoke to him, and by the way, yeah, it sucks to be you guys because it's not, then I can take back what I said. I'm only going upon my best information.
Okay.
Okay, but as far as I know, yes, it'll be open book, open notes.
So, Professor, you're not the one who's going to be making the exam. It's going to come directly from the math department.
It's very possible. That's correct.
Okay.
And in that
How
case,
would they
if
know
they
what-
happen to ask something on regression, as I already mentioned to you, because it's my bad, we'll figure it out. You won't be responsible for that, even if they ask something on it. But when I taught this class the last time, which was like years ago, I'm pretty sure I made my own final. I'm pretty sure I wrote. It's been a few years. I'm pretty sure I wrote my own final. Not 100%, but I'm pretty sure. Sorry, was there a last question? Tomas, I thought I heard you or maybe someone else who started to ask a question.
Oh no, you're good. You answered it for me.
Okay. So what's my advice for studying? If you feel that there's a chapter that you're like, I don't really know this stuff well, the homework questions are the place to start, because the test questions are essentially carbon copies of the homework questions. They're very, very similar. So if you come across a homework question, you're like, I have no idea how to do this, then what are you going to do if it's on the test? You're just going to, I don't even know what you would do. I mean, that's what you got to study, right? You got to do the homework questions. You got to know how to do the homework questions. You really want a study guide? That's the study guide. Do the homework questions. If you can look at a homework question and say, oh, I know how to do this, and then you're good to go. Okay? That doesn't mean you should do it, because there's a lot of homework questions and it's a lot of time. But you should be able to look at a homework question and say, I know the strategy for this question. I know how to answer this one. Okay? And yeah, if you do all of them, that's wonderful. But that's a lot of them. That's what, 17 chapters so far, give or take. I think we missed 16 chapters. And that's 10 questions at least per chapter. That's 160 questions. That's a lot of questions. But if you can, fantastic. I would start now, right? What's today? Today's November 18th. So 12 days in November, 14 days in December. That's 26 days from now is the final, a little under 4 weeks. So at this point, we've done 16 chapters. That's like 4 chapters a week. By the end, we'll probably do 3 or 4 more, 2 or 3 more, whatever it is. So you do 5 chapters a week, Monday through Friday, 1 chapter a day. And then on the weekends, review them. Rather than waiting till the day before and saying, okay, now I have 20 chapters to go over before tomorrow.
No, cram before.
Yeah, okay, Adderall, that's what you want to start with, right? Okay, so you really want to study, you're worried about it, start now. Chapter 1, every day, take an hour, take 2 hours, and do 1 chapter a day. And if a chapter is quick and you finish it, then go on to the next one. Make sense?
Sounds good.
All right, guys.
So the
Yeah.
next quiz, since that's before the final, it's not on this chapter.
I'll tell you what it'll be on before we have it. Yeah, I'll tell you what the quiz will be on before we have it. Don't worry. I'll pick a chapter that the class as a general rule feels okay about. I'm not going to try to screw you over by saying, okay, what's the hardest thing you guys know? Yeah, I'll ask them that one. That's not what I'm trying to do here. All right. So, you know, we'll find a chapter. People are like, oh yeah, I get this chapter. Okay, let's have a quiz on it. Okay. So Talara's looking for a group chat study session thing. So if you want to reach out to her, or you get a WhatsApp group going, or a Facebook group, or a MySpace, or whatever
Just-
else is out there, Instagram, and
AIM.
what's AIM? Yeah, America Online.
No, AOL Instant Messaging.
Oh, AOL. Yeah, America Online. AOL. That's right.
Oh, I didn't know.
Yeah, AOL. That's what I was on 20 years ago. I'll tell you that much. All right. Anywho, I'm going to stop recording now.